Hi everyone, so welcome to this session. You guys can follow me on LinkedIn. My name is Dheeraj, and in this session, I'm just going to take up one problem, from you can say right angle triangle, okay? And so you have to watch this session from starting to end so that you can learn maximum thing, okay, from this problem, okay? I believe that many of you might be familiar with what is right angle triangle. So one of the angle is going to be 90-degree whenever we call it right angle triangle. And we can apply Pythagoras theorem, right? Whenever we get to see the right angle triangle. So let us directly jump to the problem, okay? हम प्रॉब्लम देखते हैं कि प्रॉब्लम स्टेटमेंट क्या दिया हुआ है. So ये हमारा प्रॉब्लम है, okay? लेट ए बी सी बी अ राइट एंगल ट्राइंगल. उसने बता दिया है क्वेश्चन में कि ए बी सी is going to be a right angle triangle with hypotenuse BC, okay, of a length 20 centimeters. So they have given the largest length of a side, that is 20 centimeter, if AP is a perpendicular from A to BC, okay. The maximum possible length of AP in centimeter they are asking. So you can say this kind of problem is based on optimization problem where you have to maximize the length of AP. I hope this makes sense, right? So that's why I ask everyone to stay, throughout the video so that you can maximize your learning, and certainly this video is going to help you, right? So let us solve this question, right? So let us draw the triangle, okay, and put all the vertices and all, right? So we have got the right angle triangle, so we can draw like this. One of the angle has to be 90-degree, so this is 90-degree, understood? And this has to be BC, okay? This is BC because BC length is 20 centimeter, okay? And you have to take A and draw the perpendicular from A, okay, to BC, understand? And then you have to find this value, that is nothing but you can say H, height. If it is a perpendicular distance, okay, you can say if you are drawing from A to BC, okay, the perpendicular, that is going to be a height, okay. So you have to find height, that should be maximum possible length of a height, okay. So you can say this point is P here. I believe this is fine. So this is the AP which is perpendicular to BC. Okay, so AP is perpendicular to BC. And we are not given any sort of other information like what will be the perpendicular length here on AB and what is the length of a side AC. Then you guys might think that, okay, let us leave this question, yeah? But what we can do here is we can consider this is nothing but your A. Okay, you can consider this is A and this is gonna be B. We don't know A and B, right? Okay, and we don't know the angle information also, right? Only one of the angle is 90-degree. We don't know what is the value of this angle, what is the value of this angle. So we can take this A, we can take this as B. Now we can apply Pythagoras theorem, right? So we can apply Pythagoras theorem on in triangle ABC, right? Or you can say BAC. Let me take BAC, okay, because A is 90-degree here, right? So we can write BAC. Okay, so it becomes A square plus B square equal to 400. Okay, that is Pythagoras theorem. Understand? This is equation number 1, you can say. Now, you should also know that if you are drawing, okay, this property is valid for this kind of situation whenever there is a right angle triangle. मैंने क्लास में भी डिस्कस किया है और हर जगह ही जहां जहां मैं बताता हूं तो ये कॉन्सेप्ट आपको पता होना चाहिए फ्रॉम हाई स्कूल मैथमेटिक्स, ओके? क्या बेसिक है? अगर आप परपेंडिकुलर ड्रॉ करते हैं, इफ यू आर ड्रॉइंग परपेंडिकुलर फ्रॉम द ए ऑन द hypotenuse, okay, please remember the height becomes, okay, the height is going to be what? This H is going to be the product of A into B upon the hypotenuse, that is nothing but here 20, right? You can say this is C from here to here. You know that value C is nothing but 20 only, right? So you got two equation. These are the two equation, right? Now if you know A and B, then you can easily find out the maximum value of H, right? Maximum value of, you can say, maximum possible length of AP in centimeter, right? But you don't know A and B. Now, how to decide what can be the maximum possible value of A and B? Okay, so let me tell you one very important concept. Remember this, the hint I'm just giving you. Let's say that you have got A plus B equal to K. Let's say that you have got A plus B equal to K. K is nothing but a constant. And if you want to maximize what? A into B, right? To be maximized. Understood? If you want to maximize A and B, A into B, I mean the product has to be maximized. Product has to be maximized, okay? So the possible value of A and B is going to be K by 2. Please remember this point, okay? This is very important concept. So if A square plus B square, okay, if A square plus B square is given, let's say this is given as K. And if you want to maximize A square and B square, the product of A square and B square, then in that case, A square is going to be K by 2 and B square is going to be K by 2. Please remember that. If you know these two concepts, okay, then you can easily answer the question. Whenever you want to maximize, see, you don't have to apply here the derivative concept or something, because since the problem is, asked in aptitude, okay, so anybody can solve this kind of question, right? See, if somebody is not having engineering background, okay, and they are supposed to solve aptitude questions, so they have no knowledge about derivatives, right? So they can't minimize using first derivative concept or something, right? Okay, utilizing the calculus. So what we can do here is we must know these things. If you want to maximize a product A into B, okay, so you have to take A, and one of the condition is also given, A plus B equal to some constant K. So here A equal to K by 2 and B equal to K by 2 you have to take. That is going to be giving you the maximum value of, okay, let's say that this is going to be H. Understood? So you want S to be maximized, so you have to maximize the product. Fine. Let me come back to the question now. So since we want to maximize this H, okay, so we have to maximize this A into B, right? So what can be the possible value of A and B from here? So the from equation, okay, after learning this concept, you can note down from equation 1, A square plus B square equal to 400, right? So the A square is going to be 400 by 2 and B square is going to be 400 by 2, right? So here you can say that this is going to be what? 200, 200. So from here you can find out A is going to be what? 10 square root 2 and B is going to be 10 square root 2. I think anybody can find out this, yeah? So these are the values A and B if you're going to take. So you will get maximum value of the product, right? Now let us come back to the equation number from equation 2. Okay, that is H is going to be A into B by, C. C is going to be what? That is given as 20. So you can just put 10 root 2 into 10 root 2 upon 20. So if you solve this, so you're going to get 10 as the answer. So 10 is going to be the answer for this question. Okay. So I hope you might have drawn the maximum learning from this video. Okay. So you guys can share also, right? Okay. One of the question was asked in GATE examination. I will try to solve in the next video, right? Using the same concept, right? So you don't have to use calculus concept here. Okay. Just remember, if one of the condition is given, that is A plus B equal to some constant, and if you want to maximize the product, so A has to be half of the constant and B has to be half of the constant. If A square plus B square equal to constant is given, if you want to maximize A square times B square, okay, then you can take A square as a constant by 2, B square as constant by 2. So hopefully this video might have shown maximum learning to you, right? So please remember, if you are new to this channel, subscribe it, share among everyone. Because we are going to come up with gate computer science and data science courses, okay, as well as electronics courses, okay, after the gate, once the gate examination is going to be over, right? So thank you so much, keep learning, we'll meet in the next video.